Hi everyone, welcome to MathSpellBook. I'm your host Peter, and let's just get into it today. Okay. Let me just... Okay, here we go. Yeah, the reason why I'm not talking that much is because my frames are like very low. I'm still recording this stream, but like I think for all of our friends on Twitch, like they're probably experiencing like some major droppage. Okay, we're in the yellow bars. Hopefully we get to green. There we go. There we go. Sorry about that, guys. All those that are watching this on Twitch. If you're watching this on YouTube, you don't have to worry about that issue. So, I thought that we would probably do like proof exercises from this book. It's called Real Analysis. Like, I'm not gonna click on the cover because unfortunately this doesn't have bookmarks, so I have to like basically stay on the page that I'm on. So I think this is a book that's supposed to be like explains real analysis in a very I wouldn't say clear cut, but sort of like a much clearer than like say like Baby Rudin or something. So I thought I would just try the proofs in this book to basically help solidify. I did read the first chapter and I took notes on it while I was like, you know, while we were like away from stream. So hopefully the notes that I took were good enough for this. Yeah. So the first exercise is like explain the error in the following proof that 2 equals 1. Let x equal y. Now, I did try to answer this morning. Oh yeah, it's pretty hot. Yeah, it's pretty hot here. Hey Sascha, hey Jose. Welcome guys, welcome, welcome, welcome. Yeah, the only thing I think I saw, the error in the proof, is that when I see this line over here, line number, I will say line number 3 here, I think for here the logic doesn't make sense, because if x is equal to y, the only explanation I can come up with is x is equal to y, then it would be y minus y, and then y minus y, and then it would be 0 on both sides here, which doesn't lead up to this part. Now, I don't know if I'm right in that assumption, because like that's the only thing I can see that looks like it would be, I guess, like close to finding an error, because the algebra does look like it makes sense, but the only thing I can see is that basically this, if you assume that x is equal to y, then these two would probably result in 0. Now I don't know if that's the right way to think about it though. Here it feels like the temperature is, which is yeah, I'm guessing it's probably hot for you guys too. Yeah, that's the idea. Is that the correct way to think about it? Because that's the only thing I can see that seems like it makes sense. Yeah. Okay. Thank you for confirming that, me guys. Okay, so I think this one was it was pretty it was a little challenging. I had to really look at it. I'm like, the algebra makes sense, but then when I look at it and I think about, oh wait, it said let x be equal to y, and I was like, okay, so let's see if we can use that. And then I thought about it and I was like, oh wait, this is like, if y is minus y and y minus y, then that equals 0, then that means that these two would equal 0. So I was like, okay, that's the only thing I could see. And I was just glad that it wasn't like something like out of the ordinary, where it was like you know, it was something like this, but you didn't see it because you don't know this and this. And I'm like, oh, okay. Okay, so I think we can delete this. Yeah, delete that. So now we're gonna do the second exercise. Oh wait. Oh, these are different. I actually have the physical book, and this one is different than what I have in the book. Interesting. Okay, we'll do them anyway. Okay, exercise 2. Cancel law doesn't hold up if you multiply by 0. So if you have that's a formal statement for the canceling law for multiplication. Oh, I didn't even know I had a name. Interesting. Doesn't hold if you multiply by 0. So if you have, that's the formal statement of the cancel law for multiplication. Okay, gotcha. Let me see if I can turn Twitch chat, but I'll just move it. So you guys are usually up here, so maybe I will move you guys down here. That way, because I usually write like usually since I write with my left hand, I go like curve up. So maybe that will probably be better. So that way, Twitch, you guys are still engaged in the stream. At the same time, it's like you guys don't feel like you're blocking the writing. Yeah, for a ring, this property can fail. If a ring has this property said, it's an integral domain. Interesting. Okay, so let's see what exercise 2 is. If A and B are two boxes, possibly with things inside, describe the following in terms of boxes. Okay, so I'm guessing they're trying to step you up for proofwriting. Because that's interesting, because I actually have a different exercise 2 in my book. Okay, so in this case, exercise 2. So let's say we have, let's see, things in it. So let's assume, so let X be an element of A and Y be an element of B. Describe the following in terms of boxes. So in this case, A, now let's see. So in this case, the box would contain. Now I gotta remember because I always forget. Is it the one in the beginning that is taking out? Because I think it's without A but with B. So I'm thinking it contains Y. And I know this is a power set, so PA, so the box contains so it will contain little boxes of all. Well, that probably is not a great way to define it. I was gonna say all combinate. Well, let's just write sets. All sets within A. I mean, it's a good way of actually showing, like, you know, better understanding of proofs. Of sets this way, making it like boxes. But I like the type of exercise where you have to find the mistake. They are pretty good. Oh, okay. I mean, yeah, because like the thing of it is that like you got like the chat is still blocking stuff. I could have made the chat transparent, but like if I did, it would still be blocking stuff. I guess I have to keep a better eye on that. Okay, so box contains boxes of all. Maybe I should write each set. That might make it a little bit more clear. Of each set within A. And the next one I think is, that's the cardinality, isn't it? So then this one would be the box contains notation for cardinality. Unless that's supposed to be just the absolute value. The absolute value of a set. Can you have that? I don't think so. Usually I'm just thinking of absolute value with just numbers. I mean, just elements in a set. Because I'm thinking this is just the cardinality. Copy this, paste, drag you over here. Let's see, if A1 and A2 and A3 and AN are all boxes, possibly with things inside, describe the following terms of the boxes. Okay. Actually, I haven't worked with the big union and the big union and the big intersection. Oh, this one, yeah. Maybe I should just rewrite this to make it... Yeah, because you're probably right. It probably is not. It would contain all of elements in B, but not in A. Yeah, I think that's a better way of writing it, because that's what I was thinking in my head. Thank you for like pointing that out, Jose. But there's also an empty set and A. It's cardinality here. I think so. The number of elements of yeah. Okay. Well. This is why I love when you guys reply whenever I start answering problems, like once I get the answer in, because then you tell me where my logic is wrong and where my where I'm actually doing good at. So, you know, I say something good and say something like that needs improving. I think that's it. That's how we help each other. I mean, hopefully one day I'll be able to be skilled enough to like help you guys out so that you guys can like go to higher deductive powers. Maybe one day, but I don't think that day is anytime soon. Maybe I'll just say something and then you guys will be inspired. It's like, wait, I didn't think of that idea. And then you'd go home and then you start writing stuff on your own board or your own computer, and then suddenly like, I got an idea. I got this idea, and I think it's like the proof is solid. That's right. It's the opposite. Oh, okay. Yeah, I always forget this one because it's like, is A the one taking out or is it B? Because I also get mixed up with the what is it? The division symbol. So it should be all the elements in A but not in B. Okay. Thank you. Sorry. So for the union, so that means it's going to contain everything within every element. So within every set, I should say. Oops, not I. 2 dot dot dot. Now, since this is a union, it's supposed to contain elements of each one of these, or, well, you know, yeah, it's supposed to contain all the elements within every one of these. But that doesn't mean that the elements are included with them. Like, I mean, they're not sharing the same elements. So it's like everything in this thing. Meaning, because I think I've seen this before, and I think like for the intersection, it's supposed to be the empty set, because like all of them have the empty set in common. If it's like the intersection, if they don't have any elements in them, like elements that are in common with each other. For the union, I think it's supposed to be I think it's supposed to be the first one. Like you're supposed to write like A1, because it's supposed to contain like every single thing. Just trying to make sure you guys can still see what I'm writing. A1, A2, dot 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 dot, AN. Now I think this one, like if any of these don't have an element in common, then usually I think they would share the empty set. Now, for this one, I think it's supposed to be like A1, because it's supposed to contain all the elements of every single set. Now, the thing is that because I'm trying to make sure that it's logically coherent, because if it's, because it's supposed to be, let's say if we have like A1 contains X and A2 contains Y, and then we can continue down the line, like whatever things, we can make up Greek letters if we want for like the other, I guess like infinite amount of sets that are there to N. It would have to contain all of those. That's how I'm envisioning in my head. And now I have to think about, okay, so for the union, how do we summarize that in one thing on the right side for it to equal? And the thing is, I get a feeling it's like, because I feel like I've seen this before, and like my memory keeps telling me it's like it's A1, but I'm not like, I think my brain doesn't have the logical foundation to actually show that that is right, because in my head it doesn't seem like it is, because we have an element of each set, right, and they're all combined together to form this union. And if they all have different elements, then like I know, let's say like if X is an A1 and let's say like AN, it contains gamma, right? Then gamma is not in A1. So in my mind, it doesn't seem to make sense if I just write A1, because it doesn't contain all the elements within the union. Yeah, it's going to contain X, Y, and everything else, as you said. Yeah. I think it's because my brain is telling me it's like it's going all the way to an, right? And let's say we have a bunch of singletons, right? And and there's a singleton within each of these sets. The thing is that like I know that once A1 contains a singleton of like one element, whether it be X or whatever we made up, and then like AN would probably contain a singleton of like gamma or alpha or whatever it is, and I know that with the union, it's supposed to contain every single one of these singletons that we have thought of, whatever they may be. And basically, breaking it down, I know that A1 doesn't contain like all the singletons we need in order to say that this is a union. Oh yeah, there's the OR thing. Yeah. You're right. It is like yeah, because it contains one of them or both. Okay, yeah, that makes sense. So, I mean, then let's say it would basically A1 or A2 or A. Now we have a vast majority of them. Yeah, I forgot the OR part. Yeah, that makes sense. That makes sense. So if it's OR, then does that mean it could be like is it just like AI in this case? Because it could be either one of them then, at that point. Because I mean, we just have AI here, but I don't know if that counts as an answer. Because it could be either one of these sets then, if it's the OR statement. So that means either one of the sets is correct, so I guess we can write A1. I mean, but that's not absolute though. I don't feel like that's the coherent answer, but if we have the OR statement, then it can be an answer, but it just seems like it's a real array of diverse answers. If you guys are watching this on YouTube, like all the mistakes I make, you can put it in the comments down below. It's like, oh, you missed this one, you're missing a step here, or yeah, this is wrong, like this problem is wrong, like, and you type out a full paragraph of the solution. I know I'm not gonna get everything right. That's part of like doing these proofs. It's just to endure the struggle and get used to the fact that I am going to struggle a bit. Yeah, because so it could be A1 or A2. It could also be A3 or, other answers. So it seems like it could be like, I guess we can say it's AN, because like AN kind of encompasses like every single thing in there. It could be A1, A2. Yeah, I think that might be it. It might be A1. I mean AN. Because like n could be any number, like any integer, or no, any natural number. Let's just say that for sure. No, it's fine. I think like I kind of answered my own question. I mean, if that's incorrect, like you guys can tell me, whether it be in the comments in YouTube or whether it be on the Twitch chat. Okay, so we got 4. Oh, De Morgan's laws. Okay, this is the one where we actually have to do some proof writing. Okay. I think we can just paste the same problem here. That way I don't have to rewrite it. Go down here. I don't know, is AN contains every element other than... I think the reason why I wrote an is because like it's like kind of abstract, because it's like n could equal 1, a can equal 2, a can equal, you know, n. You know, that's the reason why I wrote an, but like I wasn't sure if I can also write ai in this case. Okay, so the following are special cases. Oh, thank you for the follow, Workman. I love how you put, like, double the letters. Workman. I'm guessing you're, like, being productive in your own end, because you call yourself Workman. If you're in the chat, like, how are you doing today? How's your Monday going so far? Okay, so what's the best part of your day so far, Workman? And are you a graduate, an undergrad student? Are you a graduate student? Or you just love math and physics? Let's see. The following special case is De Morgan's Law. You're French? Oh, okay, okay. Dang, I'm having a lot of people from that are French. I guess you guys must really love math. I mean, Sasha's French. I think Jose, you speak French. I don't remember if you actually are French. And I know you're like studying in Europe, I think, right, Jose? Okay, so prove that is okay. I think I've seen this problem before, but I don't remember how to solve it, so okay, so proof. Let x be an element of A and let y be an... Well, actually, I should probably just write their lowercase versions. That way we don't have to like fiddle around too much with like different words. It's B. And this one, I think it's supposed to be the complement, so it's not either of these, because so maybe we have to make up another variable where it's like and so A and B and C. Now I'm debating whether she should be the complement or it should be the intersection of A and B. You know what? Let's write n for the intersection of A and B. So n is an element of A and B. So now we have to think of the complement to it. So now Maybe with C here. It's time to play with definitions. Yeah, it is. So with the intersection, it has to be A and B, but since it's the complement, it's basically neither of them. It would be funny if you just wrote, then it's the universal set. I'm kidding. Okay, so let's and then I think we'll put C naught. No, just that's not a complete sentence. Then C naught is an element of complement of the intersection of A, B, C. Now, well, actually, we should probably write the definition of what the intersection means. So, by definition, I was writing of the intersection I'm also trying to make sure that I don't write into the chat so you guys can see what I'm writing. Section of sets C is an element of A and element of B. Okay. So according to the way that, so if we have a complement of A, then that means it's not in A. Like, I'm trying to do what Sasha suggested whenever he told me about proofs. It's like, think of the right hand side, this side, as the challenge. So you're basically using this side to actually form, I guess, the whole thing. So if we think about this, so if it's not in A, then that means it can contain B, but I don't want to just flat out say it. It can be an element of B, of A, C. So by definition of a complement of a set, I know I'm probably making it wordier than it needs to be. B is an element of A, C, and A is an element of B, complement of B. It really depends on the situation. Sometimes starting from the right hand side is easier, sometimes from the left side is easier. Oh, okay. Because technically they can be elements in a, because is not the elements contained in A, because they're complements. So okay, so And since they're a union, then that means by definition of a union of sets, the union of the complements of A and B is such that A I want to make sure that I write this correctly. Should I use different letters? Because I want to make this like broad as possible, but at the same time that broadness is going to give us the chance to actually put A and B in. But I don't want to mess it up. Such that maybe I have to write like element n of the union of the complement, but then I have to put this in parentheses here, such that no, I think that's not the right way to write it. Didn't feel right to me. Can you guys still see what I write? Yes, okay, cool. By definition of a union, because I feel like I know what I want to say, it's just that I'm just trying to formulate the sentence, and that's the hard part. I think that's always going to be the hard part when it comes to like proofwriting. So A such that B is an element of C, or A so A or B in this case. Now we have to do the other side, which is the intersection. Now, the thing of it is that I know the complement is supposed to be not what's in the parentheses. The thing of it is that is the complement supposed to like alter the sets along with the operation that's in it, such as intersection or union, or is it only altering the intersection or the relation, I should say, in the set? That's the one thing that I'm trying to think about, because when I think about it as just, oh, the complement is supposed to alter the operation in between the sets, such as intersection and union, then it makes sense, because it's like but then again, if this does make sense, then basically the complement is going to all of them, such as the sets and the operation that's going in between. I say operation, and that's probably not the right word to use, but the process of what's going on between the sets. It's a complement of A intersection of B, yeah, because the parentheses, yeah. Because it's supposed to show it makes sense, so now we have to prove that the intersection of A and B complement is equal to the left-hand side, which we got. And what we got was basically like, it can be either the elements of, you know, the complements of either of the sets, or like the other set. Now we have to actually show that on the other side. Now the question is how do we go about doing that? So if it's an intersection, we'll basically say, since C is an element of A intersection B, then C is an element of A and B. Okay. Well, that's a complete sense. I was wondering for problems like this, if it would be valid to make a truth table, like, you know, with Boolean logic. Yeah, it would. It would. You could make a truth table. I just find it very tedious to make it. Like, I'm not making it because I'm kind of lazy. I could, though. I could make it. And that probably might help structure a little bit. Replacing complement by not union by or intersection by, and it's kind of the same thing, and the result's the same. Yeah, pretty much. Yeah. Yeah, you guys are so smart. You guys are so smart. I'm like Homer Simpson in that meme where, like, well, I don't know if it's a meme, but I know it's like a short, like, on YouTube. Like, he basically gets a degree, and then Homer ends up burning his house down, and he's just dancing, I'm so smart, I am so smart, I am super smart. And he just burns his house down. That's literally kind of me. Yeah, that's what I was thinking. Yep. Okay. So C is an element of A and B, but if we have a complement, then that means so complement of A. Oops, not that writing. So A intersection B complement means that C is not an element. We'll just write that. That's actually pretty obvious. C is not an element of Hopefully I don't make it more complicated with this. I'm just basically trying to build up so it looks like the proof is going in its in a coherent fashion. So if C is not an element of that, where does that lead us? It's like you basically have the idea and it's on the tip of your tongue, but you're just basically like not formulating the right words. And like that's what I am in right now. It's like on the tip of my tongue. But actually, Syntax, what's the best part of your day so far, my friend? I know it's Monday, and Mondays are usually, like, pretty intense for people. But hopefully there was, like, at least one thing that, like, got you, like, started. Okay. So C is not in, the complement. So No, that's a leap. I was going to say that so C is not an element of the complement of A and B. So I was going to put that C is not an element of A complement and B complement, and I'm like, no, that's probably too much of a stretch. I'm on the summer vacation, so it's a good day. Ate some leftovers. They were good. Oh, what type of leftovers did you have? How do you prove the two sets are equal? Oh, actually, maybe I should put this in parentheses. That makes it more coherent, because then it would look like just C is an element of A. I gotta remember that. Okay. Maybe that's a hint. How do you prove that two sets are equal? Because we know we have to make it so that it comes out with this, or something similar to this. So... I mean, logic-wise, when I'm thinking about it, because like since C is not an element of the complement, and A and B are in their separate domains, or I mean their separate sets, I should say. I shouldn't say domain. Then A within A, and well. I had a thought in my head and I was like, wait, hold on. I gotta slow down here for a sec. A and B. I don't know if that's too much of a big leap, but at the same time, it kind of feels like it makes sense. I mean, to me anyway, because since it doesn't contain C, which is contained in both sets, then that means it must contain something that is separate in the set separately. And A and B do fit the bill of like not being in the intersection of this whole thing. Now, we're not finished yet, because I know we have to, like, get the OR part, because we need to get the OR line in there. Now, I mean, it kind of is kind of built in, because it's sort of like, we can choose either one of them. And they're both from separate sets, so because they're not included like with each other. I think like what I'm struggling with is like how do we say that it's not an and statement, and how do we say it's an or statement? Wait. Maybe if we include the set symbols. So it's a set of A and B. But that doesn't make it not an and statement though. We have to show that it's either one of them. So do I have to just use set notation for this? Because it feels like it's just too simple if you do it set notation. I mean, maybe. Oops, not intersection. Set AB is maybe I should write element. Maybe writing an element, maybe writing that as the element makes more sense. Make it look better. Oops, no, don't do that. Do not do that. Set A, B is an element of A union B. Oh, happy Monday, Zach. And if you guys are not familiar with Zach, aka the E to the 2I pi, they're another awesome math streamer. Check out their content. They basically will do proofs. They will also do like infinite series. And Zach, you just got your PhD, right? Your PhD diploma. Congratulations on that. So he is a certified doctor now. So professor, you're in the house. Congratulations. Yeah, no problem, man. Like, you know, like you've hit a pinnacle where like a lot of people that love math like want to get to, you know. So you're an inspiration. You're an inspiration, my friend. How are sets and their complements doing? It feels like I have an idea Like, I feels like I'm actually on the right track, but at the same time, I don't know if I'm phrasing everything correctly. So, I feel like we're getting very close though. So then, A and B are elements of. Is an element of the union. I think we can say that because the union includes all the elements, including A and B, so I think that qualifies. Or maybe I should say it's a power set. It's a power set of the union. No, I think that may make it too complicated. No, you need the element from the left side to show that it is in the right side. Do the same thing in the other way, and you'll get the... So am I doing it wrong, Jose? I mean, maybe I'm on Twitch 10-year track. That's funny, Zach. That's very funny. I mean, I feel like my logic is like coherent. And plus, Jose, I don't know how much of a like lag the stream is where you're watching this from, because sometimes like I think you type something and then I'm probably like already ahead of what you mean to what part I'm at. So hopefully there isn't too much of a big gap. So let's see, because I think the structure is, I mean, I did wrote by the definition of certain things, and I probably shouldn't have wrote those. Probably made it too wordy, but I think it was the only way to keep my thoughts organized. Okay, so since C is is an element of the intersection of A and B, yeah, it's kind of complicated. Let's see. Yeah, it's kind of complicated, and the set A is an element of the power set A, not an A, and it's not the best idea. Okay. So the thing of it is that we know that these elements are going to be in A and B, so probably we should take this out. Since A, okay, so this one should make sense. A and B are elements of the complement here. The complement of the intersection of A and B. Now, we're so close because the elements are in here, it kind of feels as if like it could be an and statement where it's like A and B are in here, and it kind of makes it like an intersection of its own, but they're not in the same sets, so it's technically a union if these two elements are in here, but it could be either A or B. So I think stating how to write that is gonna be a little bit hard. Oops. I thought I was still in pencil form. Yeah, like I'm so close to finishing it. It's just that what is it that I am not thinking about that can make this an or statement, like this part? So wait. For some reason, I keep thinking of this relationship. Is equal to, union of it. Now, I'm not writing that in the proof. It's just that I'm thinking of this relationship. But the thing of it is that would a union be like the symmetric opposite to an intersection? How can you translate that an element X is in intersection A and B, for example? So basically you would have to write X as an element of A and B in that case. Oh no, you wrote the complement on the side. I didn't see that part. So let's see, how do you translate that the element X is in the complement of the intersection of A and B? Then that means you would have to just write so then, since it's not the intersection, but it's the complement of the intersection, then that means you would have to write that X is X is A or B in that case. If I'm thinking of that correctly. So maybe that's what we need to do. So in this case, such that the thing is that that are and A is an element of B complement and B is an element thus I think that's it. I mean, I think that's how we set up the logic. So my previous statement was true. What you can say about the intersection of if you let my B equal A intersection B, let's take a look. I mean, I feel like the structure is, let's see, then A and B are elements of, no, Since A is an element of A and B is an element of B, A and B are elements of the A intersection, the complement of A intersection B, such that A or B is an element, and A and B thus. It feels right, although I don't know if that's like accurate. I don't know if that's like accurate enough for a proof. Because I feel like with my intuition of the definition and stuff, it feels like it's okay. It just doesn't feel solid. And I don't know what I'm missing though, if that's the case. Or maybe I'm just overthinking. I mean, it just, like, to me, it kind of feels like it's right, but at the same time, it's like when you write an essay and you feel like you've done all you could, and then you realize that you feel like there must be something that I missed, but you just don't see what you missed. And I think that's the thing that I'm kind of giving myself for, but maybe I should stop doing like that analysis paralysis. maybe that's a new term that people that are in undergrad should like take on. It's like, oh, you have analysis paralysis. Because it is real analysis. But I feel like everything is fine. Okay, I think we can move on to the next thing. If you guys are watching this on YouTube, you can basically put in the comments. It's like, oh no, you're missing this one step or something like that. You can put that in, when. I think you still have a bit of trouble with complements. The statement A and B and complement C, and since A and B isn't true. So what do I have to change from here? That's the thing that I can't, that I'm not, I guess I'm not seeing. Like I said, my intuition is not that great. I don't know if I said that before, but I probably will mention it now. Because I keep looking it over and over again, and I'm like, okay, what is it that I need to do? Like, what is it that, because we know that, because based on what we wrote in the beginning, let A be an element of B, let A be an element of A, and B let be an element of B. Like, the reason why I wrote this is because they are separate. Like, basically A and B are separate from, like, each other in the intersection. So that's why I wrote that A and B are elements of the complement to the intersection. But did I fully wrote that so that it's clear? Maybe I did not. That's the thing that I'm trying to make sure of when I check this over. Little help if X is in then X isn't in A and B, then you can say something about X being or not being in A or B. So I should replace A and B then in this. So I should just turn this into X then, into like a whole different variable then, right? Is that what you're saying? You don't need two elements to prove the set equality, just one. Yeah. Okay. Then... No, I don't want to write by definition. Therefore, X is an element of great. Now I have to think about, like, because since the complement is in the parentheses, like around the parentheses, now I have to think about this for a second. Because I want to write X as an element of A or B, but then like I have to think about it now. So it's like, because it's supposed to be not in the intersection. So if it's not the intersection, then maybe I can just write it. It's that analysis paralysis thing again. It's like, because like now I'm thinking that X is not in the is in the complement of A or it's in the complement of B. So maybe write that, I guess. First of all, X is in the intersection. Yeah, that's the one thing. Therefore, X isn't in A or isn't in B. So yeah, that's why I wrote X is an element is an element of the complements of them, unless that's not right. Or am I like totally missing exactly what you're trying to explain, Jose? Which is probably likely. You probably already have like a broad bird's eye view of what you want to see, but then like I'm not seeing it because I'm only like 3 or 2 steps behind. Then X is in the complement, and boom, you prove that A intersection B complement is a subset of. Okay. That's what you were getting at. Okay. Okay, so that's what you meant. Okay. Yeah, I thought it had to be exactly the same. That's why I did A and B. The small a and small b, like the underline here. I thought I had to get it exactly looking like this. That's what I was thinking. But I see what you're saying. Yeah, this is why it's a little bit more abstract to think about it. And it does make sense because X can be considered like, kind of like a, instead of having two elements. Now I kind of see what you mean. Okay, that's another trick I didn't think about. Therefore, X is an element. Okay. Alright. Now I see what I went wrong, and it's less wordy than what I wrote, so I think that's much better actually. But thank you, Jose, for like explaining that. Like, I felt like you were seeing like a big, huge portrait, and I was only seeing like little pixels. That's why I was kind of like struggling a bit, because I was like, I know my answer is not completely right, and I have to like, but I can't find the flaw in it. Here we only have a part of the subset, but you should do the other way, starting from a complement and union B complement, and go to the intersection A and B. But to win a bit of time, you can go the second one if you want. I mean, we did do that. We did went from like A complement and B complement first. And the union, I mean the left-hand side. I mean the right-hand side, sorry. We went from the right-hand side first, and then we went back to the left-hand side. But we could have done the left-hand side first, though, from the way this was structured. This one probably would have been a lot easier, like if I knew this relationship, I would have probably done that, and then probably gone back to this side. That probably might have looked a lot nicer writing the proof, because then it goes like nice left to right. But, you know, it is what it is. Okay, now I think we can do number 5. I mean, like, based on what you observe of my proofwriting chat, what do you guys think of my progress in proofwriting so far? You could be honest. Okay. Given an ordered field F, recall that the definition of the positive set. Okay. We have to get the definition of a positive set. To be non-empty subset of the field, positive set, that satisfies both the following properties. Oh, okay, we already have the definition here. If A and B plus, right? And if A, okay, so it's nice that they put the definition for us, so we don't have to worry about that. A is an element of F, and if A is not equal to 0, then either A is in the positive set or A is in the. Oh yeah, this one was this one. When I saw this in the book, I had to reread it twice, and I was like, wait. So it can be that the negative number is in the positive set, but then the positive one cannot, and then or like both of them are, and I was like, that left me in a, oh no, not both. Yeah, it says but not both. Okay, yeah, right. So basically it could be either or, but not both of them at the same time. And I had to reread that twice, and I was like, wait, what? I stared at it and I was like, what? I'm pretty sure there are times when you guys probably have encountered stuff like that. Give an example of some P1, a subset of R that satisfies 1 but not 2. Okay, and give an example of some P2 of the subset of R that satisfies 2 but not 1. Okay. Example, huh? Okay, so proof. So let P1 subset of R. So it has to satisfy 1, but not 2. Okay. So if A is not equal to 0, then either A. Maybe I had to think deeply about what number 2 means. Because I know it basically says that A, or negative A, is in P. But the one thing I'm trying to think about is, like the mathematical arithmetic that we're so used to, like the calculations. I'm thinking about when would a negative number be in the positive set? And I'm thinking it would probably be when it's like just like when you're doing subtraction, or basically based off like, say if you have like A that's less than B and it's like B plus, like B plus, like say negative A, and let's say it's like 2 and like A is negative 1, and then you have like B plus A, so then you would have to get like positive 1 at that point. But then I'm trying to think about like other examples, because I know, like I think the most cumbersome thing is the second definition. I mean, not definition, but the second part of that. And I think like there's some like tricks that you have to like remember from like doing basic arithmetic to actually like fully get the definition of it or what it's talking about. Oh wait, hold on. Was there 2 parts to the last question? Oh yeah, we have to do another thing. I forgot B. This was just A. So what does B say? I'll prove the union. Okay, prove that the union and okay, so we gotta do that part. I almost forgot about that. So B, we have to prove so A union, not union. Union but not union is the same as complement intersection C. Okay. Alright, so I guess we have to write this similarly, but maybe a little differently. So, proof. Okay, so let C be an element of. Oh no! Wait. This is union. So yeah. So this is union. So it's going to be like let A be an element of A, and let B be an element of B, and by definition of a union of sets, A is an element or Therefore, an element C is an element of a union complement. By definition, complement. Okay. See, let A and B. Let A be an element of A and B be an element of B. Definition of a union of by the definition of a union of sets, A union B such that A and A or B and A. So A and is not an element, therefore an element C. Okay, so now We don't need to write that detail just yet. I mean, that probably might not be right, so I think we'll just leave it like here. Then okay, so simply since we have these elements, so let's say we have B is equal to AC and A is equal to, well, is an element of BC. Oh no, yeah, so it's an element. That means if we have an intersection of the two, let's erase this. Excuse me, guys. Sorry about that. Okay. So now we have an intersection of the two. So by definition of an intersection of sets Thank you for that, Jose. In algebra, you say, huh? Was this from the previous problem? Is that why you wrote it? I mean the previous part? Like, the reason why I'm taking my time is because, like, I'm trying to, like, remember and try to... I'm trying to understand every step I'm taking, so that way it's logically coherent. That's why I'm going so slow, because I'm, like, constantly rereading what I'm writing, and I'm constantly, like, looking over. Of the intersection, an element y. So far with Jose's help, I've been like understanding a little bit more about what I'm like getting wrong, because so far I think the hardest thing we were doing is basically doing De Morgan's law. That's like the challenging thing, but I'm going very slow because I'm basically trying to look over every single thing I write, and I'm basically just trying to make sure that I understand every single step that I'm doing. Let's see, since A is not in B and B is not in A, then A is in the complement of B and B is in the complement of A. By definition of the intersection of sets, there exists a Y. Maybe I should write there exists. Such that Y is an element of A, complement A, and Y is an element of a complement B. Thanks, Sascha. Like with these proofs, I feel like I'm starting to understand the structure of it, like how these are supposed to be written, sort of. Am I 100% certain that I know how to do proofs involving De Morgan's law? Not really, but I feel like I'm starting to develop the muscle though, like bit by bit. By definition of the intersection, there exists a Y such that Y is therefore the element C. Since A and B. Maybe I have to write something in this part, like after this part. I feel like I'm missing something here. Can I... Oh, I hate that. I can't move the whole thing. Maybe I can... That's the one thing I don't like it when I write crooked. Now the thing is that I want to take this and move it. learning from ourselves isn't an easy task. Do you mean like self-study, Jose? Is that what you mean? Or do you mean me learning from chat? Therefore, the element C is... Therefore, an element C is an... Okay, so that... Because it defines this relationship. Now, since A is not an element of B, and B is not an element of A, then A is an element of B complement, and B is an element of A complement. The definition of the intersection, there exists a Y that Y is such that Y is an element of A complement and B is an element of B complement. Now, so, I mean, technically, the way we look at it, it seems like it's structured like C. It's just that it's not C in this case. I mean, but the structure's the same in some regard, because it is an intersection, which is what the union of A and B complement of A and B, the complement of a union of A and B is. Both, I guess. Oh, have you the emote expression? No, I don't think so. Because in this part, okay, let's just move this back here. Excuse me, guys. Sorry about that. Okay. Now since A and B there's just a Y such that. Now the structure is an intersection, that is true, and so basically the first part, this part, is saying that C is basically the thing that belongs in here. And for here, we're defining the intersection of things that are not in these sets is the element that is the thing that unites the sets. Or at least like the element that belongs in both sets, which is technically an intersection, yeah. So the structure is the same. Now, the question is that, did we formally prove it though? Because we have C here, which is supposed to represent the complement of the union of A and B. And here we have basically the the intersection of the complements of A and B, which is practically the same structure when we think about it. So my question is that did we formally prove this? Because I feel like we kind of did, but I'm probably missing a few words or a sentence that doesn't tie them all together yet. Because we did show the left side, and now we're showing the right side. And the right side shows that the structure is pretty much similar. Because this requires like one element in this case, and this one requires one element too. So that's the structure, that's the same. Because I think this one, we basically proved it by, we let this C, and the C's are right, and then since C is an element, I mean, it feels like we did this, like almost similar structure than we did with the first one. It's almost similar. I mean, it's just a little different because we're working with union to an intersection, but the structure seems the same. Luckily I caught that, I caught that we had to do this, because I was like, wait, I feel like there was a second part to this problem. When I was doing this, I was like, oh my gosh, we're done. But then I'm like, oh wait, there's still one more part here. Let's see. For some reason, I feel like we should probably write if C is equal to F. I mean, if C is equal to Y. Why did I say F? If C is equal to Y, then we get a relationship, but that's probably an overstretch. Because the structure is the same. I think the structure is the same, like the way it's like made here. Because like, when we think about it, C has to belong in this whole thing, but we don't know exactly what this thing is supposed to entail. Like, we don't know if it's the opposite of like the union. I mean, it's supposed to be not a union because it's the complement, so not a union. And then this one basically it's talking about things that are not in sets, but there's an operation that talks about something about those sets. About those set elements that don't belong in their respective sets. So the structure seems like it's fine. Yeah, I don't want to go through like analysis paralysis again, but I feel like that's pretty good. Like the way we set it up. I mean, like there might be some holes. If you're watching this on YouTube, like, you know, put it down in the comments down below. What is it that I'm lacking in this part of the problem for exercise 1.4. But yeah, I think we did pretty good. We did like some simple, we did, I guess, some problems that are like considered like quote unquote simple for like But yeah, like anyone in the Twitch chat, tell me like what I'm lacking in here, like in B, if you want. I don't know if we're gonna do all these problems because this chapter has like 37 problems in it. I think it has 37 or 40. Let me check. Oh, it has like, oh, in this book they have 26. When I look at my book, it had like 37, I think. Because according to what this book says, okay, we did an important one. Yeah, we did this one, the De Morgan's Law. So we actually did the one that is in this important problem, an important part, because there's actually important problems that the author says that we should focus on. So, okay, you guys can read the whole thing, cool. Because, like, we had to focus on this problem, which I didn't know we had to do, but I guess we did it. Another important problem we have to focus on is 1.9, which is which talks about the epsilon property, which I think we're gonna be like having our. I think this is like one of those problems where it's gonna be like you gotta remember this for like the whole entire course, the epsilons definition, and then we have 1.14. This one I'm pretty excited about, exercise 1.22, because it says the same thing in the book. It's like typological properties, which goes into topology, which is in chapter 5, which I'm pretty excited about. Will I understand? Actually, we can take a sneak peek, and let's see what that says. Okay, here we go. For each n in n, assume that the given closed interval, okay, so we have to know what a closed interval is, bn, an, and bn. Also assume that in plus 1 is contained inside in, okay. This is given a sequence increasingly smaller interval, okay. So we're having, okay, so this is a, hold on, I want to make sure that I'm not reading. Okay, yeah, okay, so I1 contains I2 contains, okay, so it's like constantly containing each other, okay. Okay, prove that the intersection of the intervals is not equal to the empty set, okay. I'm thinking that's the empty set, yeah, because that's not 0. That is, prove that there are some real numbers x such that x is an element of in for every n in n. Ooh. Yeah, that sounds like a pretty interesting problem. Will I be able to prove it? We shall see. But I don't think we're gonna get there. Let's see, what is this one? Okay, so 1.9. Let's see what this one says. Let A and B and epsilon be an element of an ordered field. Show that if A is less than B plus epsilon, and for every epsilon greater than 0, then A is less than or equal to B. Part B. Use part A to show that if A, the absolute value of A minus B is less than epsilon, for all epsilon greater than 0, then A is equal to B. Okay. Those are some of the sneak peeks of what we're probably going to work with. Yeah, because then we have what is 1.14? We can take a look at that one too. 1.14. Okay. Oh, this one's just a one-parter. Okay. Assume that A is a subset of B, and both are bounded above. Prove that the suprema of A is less than or equal to the suprema of B. Interesting. Okay. So I guess because of these notable problems, we probably we get a better idea of what to focus on. We actually worked on one, so at least that's good. I think we worked on like 4 today. We worked on 4 problems today, so I think the next stream we'll probably try to focus on these problems. Try to see if we can get these done, or at least one of them. Because I think that reduces our workload a little bit. And hopefully that gets us closer to the point where Sascha wants us to get to, so that we can actually do the next lecture on finishing the real numbers and doing linear algebra. Hopefully. And I think I like this book. This book actually talks about proofs in a, I think in a more layman's terms way, where it feels like I can obtain it a little bit better. Okay, guys, I think that will do it for today. I will upload this on YouTube, so you know, if you're watching this on Twitch, you know, I will post, I will put up the YouTube channel, so if you guys want to follow my YouTube channel, you're more than happy to do so. You can drop a sub, like, comment, subscribe on those videos. In addition, actually, Sasha, if you're still in the chat, since I read these problems out, do you think that that's gonna, is that the proof techniques that we need in order to get to the next part, or do you think we have to go further in? Because I think the next chapter's on cardinality in this book. Here's the table of contents. Yeah, because we're working with the reals right now. So the next chapter's on cardinality, and number 3 is sequences. So, like, and also for anyone in the Twitch chat, I'm also typing up the Discord server. If you want to catch us on the Discord server, you're more than happy to do so. You can join the Discord server, and if you're watching this on YouTube, all the links will be in the description down below. And if you want to check out my Uncle Talks channel, where I just play video games and just talk to you guys, that will also be in the description down below if you're watching this on YouTube, and it will also be in the Twitch chat if you're watching this on Twitch. Okay, yeah, so we have sequences, series, and then topology. So probably tonight, maybe I'll read a little bit about cardinality, because it doesn't look like it's too long. Let's see, 39, 56, if we do the arithmetic on there. That's like around 7 pages, right? No, what am I doing? Dang, my arithmetic is so bad. So then 56 to 39, that would be yeah, that would be like 17 pages? Yeah, that would be 17 pages. See, like, even though I love math, I'm really bad at arithmetic. So, okay, guys. Yeah, that will do it for today. Thanks for joining me today, guys. I won't be streaming tomorrow because I will be helping out a friend. He's like moving into a new house, so I probably won't be able to stream tomorrow. I don't know about Wednesday. I will keep you guys updated about that, but more likely tomorrow I won't be streaming. So thanks for joining me today, guys, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care, guys. Bye-bye.